Hi there, Mrs. Vaughn here. We're wrapping up our energy and heat discussion using the equation Q equals mc delta T. We're going to look at the trickiest scenario for this one where we have to try and find the final temperature or the initial temperature of a substance. So again, in orange, we have our two ways of writing this equation. Our example problem reads, a 4.50 gram nugget of pure gold with a specific heat of 0.129 joules per gram degree Celsius absorbed 276 joules of energy and had an initial temperature of 25.0 degrees Celsius. What was the final temperature of the gold? Step 1, let's write down everything that we know. So we know our mass is 4.5 grams. We know our specific heat of gold given to us in the problem. We know our initial temperature and we know how much heat was absorbed, so we know that it was positive. Step 2, figure out what we don't know. The question is asking us, what is the final temperature of the gold? We know we're going to be using our Q equals mc delta T equation. We're going to use the second form where we actually separate out our final and initial temperatures. So we're going to start by writing it as seen here in green. Our next step is to plug in our information. So in this next green line, I have just taken the numbers from our known information and plugged them in their appropriate places in our equation. But this is kind of messy to me. So in my next step, I am going to simplify. So I took this number times this number. That's where I came up with this number. So that's one step to simplification, but this is still really yucky over here. So I'm going to have to dig into my algebra brain for chemistry class and look at this and realize I can distribute this number to both my final temperature and my initial temperature. That way I have two numbers that I can work with. So that's what I did here in the next line in orange. I went ahead and I distributed this 0.5805 that I got from simplifying these two numbers. So I have this times that. This was a subtract, so I have to make sure I keep that consistent. And then I took this number times that number. This is the product here. Joules are going to remain, but degrees Celsius are going to cancel out. So we're getting closer, but I still need to get my final temperature by itself. So the easiest thing to do, we are going to add 14.5125 to both sides. So that leaves us with this addition problem on the left, but we still have this number. So I want to get my final temperature by itself. So to get my final temperature, I'm going to divide both sides by this 0.5805. So what I do to one side, I have to do to the other. Right now, these are multiplied. To get rid of it, I divide. So I divide both sides, and that is going to give me my final answer, my final temperature, TF by itself, of 5.00 times 10 to the second degrees Celsius. I had to have 3 sig figs in this answer, and rounding put me at 500, so that's why I used scientific notation here, because I needed to have 3 significant figures. I hope this helped. This is the trickiest way that I can ask you to use this equation, other than adding in some extra conversions, but finding the initial temperature would be done exactly the same way. So as always, if you have any questions, please don't hesitate to reach out, and I will do everything I can to assist you. Thank you, and good luck.